Hello everyone. Thank you for coming to my talk. I'm Vasco. I'm a PhD student at the University of Chicago. I'm actually a computer systems researcher. So this is actually my first foray into HCI research. So it's been very fun. In any ways, I'm here to present our work in interactive scissor mechanisms as portable and customizable shape-changing interfaces. So scissor lifts are or scissor mechanisms is a popular and widespread extension mechanism that is used anywhere from scissor lifts to robotic arms, which can reach these really hard to reach places while preserving this really compact form factor. We have these extendable lamps, which are this flexible furniture that you can adjust its position and length. And you even have these mechanical toys, which are, well, they're just fun. And there's actually a really exciting quiz. I'm sorry for the pun. Actually, Ken came up with it. So there's actually a scissor mechanism that is being used in this room, and it's been playing a very important role for TEI, and I'm very curious if anyone has noticed or can find it very quickly right now. And just remember to shout. Yes, that's right. So it's being used in conjunction with the projector, and so we found it very interesting when we found it out. So why the scissor mechanism? Why are we discussing the scissor mechanism? Well, the scissor mechanism has three unique features that are really interesting for tangible and embodied interaction. The first one being control simplicity, which means that you can control the shape in a simple manner, specifically 1 degree of freedom, either by sliding or rotating motion to control the full expansion. It also has high expansion rate. It has this really large expansion rate, and you can achieve these really large transformations specifically while they're being folded in this really compact form factor. It also has this modular design, which means you can break these mechanisms into small pieces and you can customize them freely. And what we seek to explore here is to apply these three mechanisms or these three characteristics to shape-changing devices in HCI applications and HCI research. Some related work in HCI, before we go dive deep into this work. In the field of HCI, researchers have explored a stream of research in shape-changing interfaces to give this dynamic form to computer interfaces for tangible interactions and dynamic affordances. These works include mobile and customizable shape-changing interfaces, which employ a lot of actuators. Scissor mechanisms have also been extensively used in HCI research, although they're mainly this auxiliary mechanism to their prototypes and applications. Compared to prior work, we instead take these scissor mechanisms themselves as a basic design for building 1 degree of freedom, portable and customizable shape-changing interfaces. We define the design space of scissor mechanisms for designing interactions, and then we introduce a proof of concept implementation, including hardware that integrates sensing and actuation, and a software for design and control. We also have applications that demonstrate the unique capabilities of X's for interaction. We begin by discussing the design space of X's and how they contribute to shape-changing mechanisms. We revisit those three features of scissor mechanisms and discuss its impacts. We start from control simplicity, which is super simple. There's only a single motor, 1 degree of freedom, to make full actuation, a gradual transition from a collapsed shape to an expanded shape. And here we have an example using a actuated single motor, or the actuator using a single motor. Next, we have this expandability for interaction. X's can be folded into a portable form factor. It can fit into your pocket. In fact, I fit one in my pocket, and then it can expand beyond the size of my pocket, interestingly, and it can fit to the size of different interfaces, and it can provide this really interesting dynamic affordance and haptic I/O due to its expandability. Dangerous. And so, X's is also modular and customizable. So you can change the pin position in these modules, or how they connect together. You can change the pin position and how they're connected together, and through that you can achieve really interesting different shapes. You can also attach you can also embed or augment the scissor mechanism with electronics. In this specific case, we embedded with LEDs and distance sensors, and whose applications will be explored later on. And then, so what we have presented is this design space of X's. And I will further demonstrate the applications later, but we first will move on to the implementation. So the overall system is composed of a single global module and multiple local modules connected together, which are demonstrated here. So there's a single global module and multiple local modules chained together, which is then chained to the global module. So we'll dive a bit deeper on how these, on what these modules actually look like. So we have the global segment module, which is this central I/O to handle the global actuation and interactivity. And we attach to it multiple local segment modules, which are then chained together through this series of pins. And we have two actually kinds of local modules. We have a geometric one, which is to explore those really interesting shapes that we saw previously. And then we have the I/O local module, which we have embedded with these LEDs and distance sensors. And they're each responsible for customizing shapes and I/O. And to save some time, you can check the paper for more detail on the specific details of the mechanism. So, to help users design different shape configurations using X's, we developed a design and simulation software. And instead of playing a video, I have decided to prepare a live demo. And this could either go very well or wholly wrong. So we will find out together right now. Okay, so so here we have the design and simulation software, and you can actually try it yourself by scanning this QR code. And let's take a quick tour. So I have to look this way. I do apologize, but we have this 3D visualization, and we have the X's mechanism here, and we can actually actuate it. And so this is a very basic configuration that just expands in a straightforward manner and collapses into in a backwards manner. Sorry. And so you can add and remove segments. You can add and remove segments. And you can also auto sweep, which is like it actuates, and you can see it really cool actuating. But the most interesting part of this system is that you can actually change the pin configurations in X's and see what kind of different shapes it can achieve. So let's try it out. So we can use these sliders to slide the different pin configurations. And so we can try to create some shape. I don't know. Maybe this, and we can see what it looks like. We can auto sweep here, so we can see that it looks kind of like an S shape, right? Kind of like an S shape. And so what I did is I actually pre-assembled this specific configuration, which I have here, and I can actually actuate it using a button, which we can demonstrate here. I can actuate into this S shape that is exactly the same as this one. We just configure the pins exactly the same, and then you can come back. And now we are unfortunately done with the live demo, but we go back to the even more exciting slides. So we have we've developed a list of applications that leverages this interactive and actuated scissor mechanism. We begin with interactive game controllers. We demonstrate an application with interactive game controllers where these different shapes can afford these different shapes that are afforded by X's can represent different like objects inside the game. In this case, we have like this fishing game where we have the steering wheel and a fishing rod, and it has this like haptic feedback when there's a fish that you can feel, and you can pull out the fish, which then pops out in the length of the fish that you caught, right? And that, yeah, this was filmed yesterday. Apologize, very dark. I'm not sure what that represents, but we have also developed a shape-changing mobile display, which uses the LEDs and the distance sensors that we have embedded into this mechanism to show the current weather. And you can swipe to show tomorrow or yesterday's weather. And more interestingly, you can expand the mechanism to show a gradient of today's weather, with the one blinking as the current weather. What we also explore is we leverage the distance sensors inside X's and also use its expandability to adapt to different surfaces and augment these different surfaces with touchscreen capabilities. So we show this on a monitor where you can actually, this is not a touchscreen monitor, but you can use it as a touchscreen monitor, and you can also draw on your table by leveraging the distance sensors that are embedded inside this I/O axis. And you can also put them on the floor and use them as an exercise mat, because because it took too long to code this, and so I needed some exercise. We also, in the paper, had an example of mobile attachments, where you can attach access devices to your cell phones, to your mobile phones, and then you can use these I/O capabilities for tangible notifications, game inputs, and a selfie stick. We won't go into detail, but please check out the paper when you get the chance. To summarize, we introduced X's, a novel shape-changing interface that can expand and collapse based on the scissor mechanism, and we defined its design space and hope that this exploration inspires further research in the ACI and TEI community to build Scissor or expandable mechanism for designing novel tangible interactions. Before I wrap up, I wanted to discuss some of the challenges and future work. The device could definitely be the hardware. Some of the hardware design challenges is that the device could be a little bit more thinner and more compact. We could have more efficiently embedded the electronics into the mechanism. We could have explored more shape versatility by introducing more degrees of freedom. And then we could also have these really interesting 3D linkages to create really interesting spatial transformations. And could have conducted user studies and can conduct user studies to see how people feel about the different shapes that X's can afford. And we can also run some workshops to see how what applications people can come up with. Talking about novel applications, we received many applications ideas during our live demo session, including like a VR controller or a musical instrument, data visualization, and accessibility. So I wanted to thank everyone who came out to try our demo, which inspired many new applications. But in case you missed it, feel free to try after the coffee break. We will have some of them here. And with that, I conclude my talk. Thank you very much. And I'm taking